Good morning, everybody, and welcome back. Let's get this day started. We're at AME Solutions with Rich Marriage. Good morning, Rich.
Good morning. How you doing?
Really well, thanks. Nice to have you back here.
Pleasure.
Rich is with us from AME Solutions. AME has been a great contributor to our yacht engineering seminars over the years. In fact, one of our initial sponsors for this event. So one of our greatest consistent contributors. The great thing about AME Solutions is they provide a different product than virtually anybody else out there, and that product is vibration analysis. Rich, give us a little quick overview of what you're able to do to help people through vibration analysis.
Vibration analysis is a very powerful tool for picking up mechanical issues with machinery. So what we do is by taking vibration data we have a database that we've built over the years that standardize places to measure vibration on a hull. We'll typically go on a sea trial and we'll identify points. We have measurement points, and we will go through the boat and measure all the machinery and the hull, and we'll pick up vibration, and we can translate that into whether it's the vessel's got a bent shaft, whether it's got exhaust issues, engine mount problems, misfire, and so on. So we're able to get a pretty good, accurate diagnosis, so you don't have to chase your tail and try to find a problem.
So on two different fronts. One, it's a comfort level, and two, it's a longevity and maintenance issue.
Correct.
That you guys are able to deal with.
Yeah.
So last year, what we did is we were on a custom sport fishing boat, and the application was a different engine mount system. And you guys were able to identify through your vibration analysis equipment that something that they had done over and over, they had to do differently on a custom boat.
Yeah.
And lo and behold, they did it the same way they always did and thought it worked, and we identified the issue.
Yep.
The great news is we identified what the issue was, what the fix was, and you showed us not only through, I believe it was your RDI equipment for the analysis, we also showed everybody how we laser target the gear to make sure that everything was aligned perfectly.
Exactly. We use we have this really cool technology. It's using video motion amplification.
Okay.
And from the video, we're able to pinpoint we'll video an object, and we can actually pinpoint vibration on that, pick out a pixel, get a vibration frequency and amplitude, and we're able to clearly identify problems.
By going back through your references, you're able to tell where that issue, where the issue lies.
And the beauty of it is you can see it. So seeing is believing. By amplifying the motion, you can show a customer what their problem is, and they can see it with their own eyes.
Perfect. So one of the great things that we have the ability to do here also is to go out into the yard and see how this stuff actually works. We're going to cut down to Heather and Chris in the yard underneath one of the boats. Chris has set up some of the equipment, and Heather's going to ask him how it works, and he's going to show her what value that equipment has in identifying issues that you may not even think would be an issue.
All right, we are here in the yard, and I want to tell you in advance, it is a working yard, so if there's any noises, if it gets a little noisy, bear with us. But I'm here with Chris at AME. He's one of the lead engineers, and today he's going to perform a bump test for us. So let's go find out what that even means. Hey, Chris.
Hey, how you doing?
Good, good. So you're going to show us today how to do a bump test, but first, tell our viewers what does that mean?
All right, so bump test, what is that? That's essentially, it can mean a lot of things, but we're working at the struts here today. Actually, let me turn on this light, and you can see these struts that we're working with. So this is where the shaft line sits. You got your propeller shaft, and then you got your propeller. And a lot of our vibration that it's pretty common is, in the hull structure, you feel the shaft rate and the propeller blade pass rate. And that is transmitted typically through the struts. And what excites this vibration is the looseness of the strut, which can amplify the vibration. And depending on our vibration analysis, which we normally conduct when before the vessel gets hauled out, we go out to the landing, we do a certain speed or a variety of speeds, and we'll do data collection around the machinery, the gearbox, and then the shaft line, and various points of the hull structure. And based on our report, we'll do analysis and see that the shaft rate or propeller blade pass rate is excessive. So we'll look into this once it's hauled out, we'll set up, with our RDI system here, which consists of our computer, RDI camera, and our nice light here. We'll use this to, do this bump test. So this bump test will, determine the natural frequency of the struts themselves, which inherently give us the stiffness of the struts.
Okay. So a bump test, it is what it sounds like. You bump it and you see how much it moves.
Exactly.
To dumb it down to a very kindergarten level, that's essentially what it is. Okay, perfect.
So yeah, we're just bumping it and then just watching it and see what it does, and then after that we'll go from there and make a report with our conclusions and what we recommend.
Okay. So let's bump it.
All right. I'll set this up real quick. I'll put the light here. So we need this light to get the camera lens here. So this is
what we're looking at. Okay.
Yeah, so I'll give you the actual mallet, and you'll go.
All right, I'm ready. Okay, where should I hit it? Right in the middle?
Yeah, right there.
Okay. All right, tell me when.
All right, 3, 2, 1. Very nice.
All right. Let's take a look.
We're gonna take a look at the vibration. We'll export it. Let the software do its,
do its thing. Okay.
So actually, let's bring it down. No amplification.
Okay.
But there, this is a pretty good strut configuration. So it doesn't move at all.
Okay. Now let's amp it up. Let's see if it moves. Maybe it'll move a little. It looks pretty rigid to me. Or maybe I'm just weak. Who knows?
Now you're standing up to a couple, almost 100-ton vessel here, so.
All right.
It's in fairness.
Fair enough.
You gave it a good hit.
Thank you.
So, actually now we'll go.
Let's try this one.
Yeah.
I'll let you take a swing this time. How about that?
I'll give you the computer here.
I'll trade you here.
And actually,
show me what to do.
So we'll open up the camera software again.
Okay.
And then I'll adjust. That's a pretty good view.
Pretty good.
So that's all we want. We want a good view of it.
And I just press record?
Yeah, just press record.
Okay.
Do this. So this is the iStrut. So you see two different configurations.
Yes.
But this is the iStrut. Typically, in most of these custom yachts, this is the configuration. It's either V-strut or iStrut. These are more prone to being a little bit weaker.
Okay. All right, let's take a look. I'll give you a 3, 2, 1.
All right.
Okay, 3, 2, 1. Okay. Yeah, you can hear that one.
All right, so I'll take this for you. We'll export it here. So we'll do non-amplified. Did it? It doesn't look like anything.
It looks like it doesn't move.
And then you really see it moving.
Oh, wow.
Yeah, we can do that again. In case you missed it. Yeah.
Oh, wow.
So this, in essence, this is actually not very bad. We have a lot of data on using this camera, and we've found a lot of issues with struts in the past.
Okay.
And we have, if we could probably share some of these videos with you. And
sure. Yeah, so now to the naked eye, you don't see it, but once you amplify the vibrations, that's where you see the issue.
So and that's where we kind of convey it. We found the issue, and we want to show it to the customer and say, here, this is the issue. Your vibration is being excited by this, and to resolve the vibration that you're feeling, this is where you want to start. And that's really helps narrow it down and convey, to people who don't really stand the vibration and like numbers on a graph. This really shows you, yes, it's vibrating.
Yes, you can see it, of course. So now we've identified the issue, but how do we get to the issue? Is it manufacturer error, user error, combination? No one's perfect.
Exactly, yes. No one's perfect. So I mean, these these vessels are normally operating, you know, like shallow water. So, I mean, you'll have a combination of, you know, manufacturing defects, which, like, I mean, before you start, you got 2 struts, sometimes 4 struts, like this one does, an intermediate and a half strut. And you got that on both sides. So sometimes, you know, going from one side to the next, it's not exactly the same. So you have a little bit of difference, and sometimes that difference isn't, you know, for the better. So
Right.
So that's from the manufacturing defect side. If there is any, it's very rare. Some more common would be like human error, like you're saying, is, you know, these shallow waters, you know, touching the bottom, you could either, you know, weaken the strut, you know, a little structural damage, or, you know, bend the strut. And this really shows, you know, what's happened. So we can also do this, you know, once we repair the strut, we'll do this video, and then, you know, a video of it, you know, fixed, and shows it, you know, not moving, and, you know, the improvement. So that's the other next thing. You can actually see improvements. You can see, you know, the root cause and, you know, the conclusion.
That's great. So you do the bump test before and after to
Exactly.
show the progress.
Yes.
Wow, that's great.
So, I mean, we could do some more today. There's a lot of things you can check with this camera, which is great. It's very useful. I mean, it's very, you know, compact. You literally just set it up wherever you want to do your findings, and you just shoot it, diagnose it, and send out the report. So
Awesome. Well, I'll be honest with you, I didn't think I'd be hitting struts with the mallet today, but that was pretty fun.
Yeah, never know.
But it is pretty noisy out here, so we're going to throw it back to you, Paul. Thank you, Chris.
Thank you.
Thanks very much, Heather. So there was a pleasure boat application again. Last year we talked about a custom sport fishing boat. Here we looked at the bump test on a motor yacht to identify an issue on a pleasure boat that maybe you wouldn't have even thought of. So not only pleasure boat applications for AME to do vibration analysis, but there's also a lot of commercial application for that. We're back up with Rich and Tony, and we're going to talk about, Rich, if I'm not mistaken, you guys had a commercial boat application all the way up in Dutch Harbor, Alaska, didn't you?
Yeah, it was pretty cool. We were up in, get it? Cool. It was Dutch Harbor, Alaska, and it was a commercial fishing boat, large vessel.
Okay.
It's a fish factory trawler.
Okay.
And they were experiencing, they have, the way the propulsion system on this vessel is arranged is they have 5 diesel electric generators driving electric motors which drive Z-drive propulsion.
Okay.
And what was happening was they were losing the electric generators, the torsional couplings between the generator and the engine was failing, and we were there to troubleshoot and diagnose that problem.
So they were losing their main propulsion system in potentially very, very deadly situations.
Yes, the chief engineer had told us that they actually lost propulsion. They lost some of the generators when they were in a 30-foot seas, and he said they can't afford that. That could be deadly.
Absolutely, that's an incredibly dangerous situation. So what you guys were able to do was to employ your equipment to identify a vibration that was causing this problem?
Exactly. And I can have Tony speak more about that. Tony's one of our lead engineers, and he worked together with Chris. Chris was in the field, and he and Tony were involved in analyzing the data and coming up with a solution.
Very cool. So I think, if I'm not mistaken, Tony, you've got a video that you could walk us through that shows us a little bit about what was going on and how you set up and how you identified.
Yeah, absolutely.
I'll tee it to you.
Play it right now.
All right, let me sneak by you here so you can show Paul what's going on the screen.
So like you guys saw with Chris and Heather downstairs, this is the setup with the camera. This is the engine room with the generators. And then it kind of goes right into just giving us a snippet of what's going on. And I actually have this source file that I'm going to play next.
Right here is your amplified video.
So that was the key thing that we kind of honed in on right away, is that motion in the frame. So that frame was distorting and was essentially overloading those torsional couplings.
So the engine itself was moving more than the torsional coupling was allowing for.
Yeah, essentially.
Okay,
Yeah.
so it was overloading that coupling.
Yeah.
Okay.
All right.
Now,
So-
was that something that you could see with the naked eye, or you couldn't see
No,
that until you
absolutely
put
not.
the equipment on?
So if you paid attention to that, I'll run this video back real quick.
Okay.
So this actually shows you the live video right here. So this is what it looks like to the naked eye.
Okay.
And then this is what the software is picking up here.
Okay.
So essentially what it does, it's a high-speed, high-resolution camera that uses the pixels in the camera itself as individual sensors.
Wow. Okay.
Yeah, and what it does is it detects the difference in light. And that difference, it essentially, as it is aptly named, amplifies that motion.
So the
that you can
software
see it.
itself
Correct.
takes the video apart and and amplifies what's going on in the video so that you can see with the naked eye what you couldn't see.
Correct.
Okay.
Yeah.
Or you can see in the video what you couldn't see with the naked eye.
Right.
That,
Okay.
yes.
All right. And there are 5 generators. This is generator number 4. I think you mentioned that was the one that was giving the biggest issue. So they
Yeah.
used that as the test case. And then didn't you say that they actually had to do all 5 of the generators, right?
They made our recommended solution. They improvised or they implemented it on every generator.
Okay.
But this was the one that was troubleshot and diagnosed.
Okay.
And then that was then again implemented on all of them.
Okay.
So, like I said before, this is the actual feed from the video software. So you look right here. This is what we honed in on. This brace right here
Right.
was not providing enough
Rigidity.
and stiffness.
Yeah.
So you can see this is the whole skid for the engine, the diesel generator.
The whole engine mount system.
So the whole skid is twisting,
Okay.
and that essentially was overloading the torsional coupling in the engine,
Okay.
causing it to fail.
So did you engineer the solution for that as well after having identified the issue?
Yes, we created an engine bracket that stiffened right here, this area, and we essentially added multiple gussets, so just support structure essentially,
Okay.
and that stiffened the entire structure.
Okay. So you were able to distribute the load more effectively, stiffen up the whole mount.
Correct.
And remove that element of vibration.
Yes.
So that the torsional coupling could do its job, because never will it be 100% true. There's always going to be a slight amount of movement, because that's by the virtue of the fact that it's machinery, right?
Absolutely, especially with diesel engines, it's just so much dynamic motion
Right.
happening.
Okay.
That is what the torsional coupling is there for.
So what you guys do is not only identify what the issue is, but you're able to come up with the engineered solution. It's not that you just say, hey, here's the problem, call somebody who can fix it. You identify the problem, and through your engineering background, Rich, I guess what you do is you go back in to say, all right, here's where the movement is, here's what we believe the issue is, here's what we believe the solution would be, and you implement that solution as well.
That's correct. One of the things that when I started the company 30 years ago was always my goal was not just to tell people what their problems were,
Right.
but to actually find a solution to their problem
Right.
in the machinery world. And it's always been our what we were all about.
Gotcha.
Yeah.
Gotcha. That's amazing. So, in a commercial application in Dutch Harbor, you guys basically made it safe for these guys to go offshore again and put the boat back to work, where they probably didn't even realize how much danger they were in until they had that catastrophic failure and lost propulsion.
That's correct. And one other thing that we did here that we didn't discuss is we actually laser aligned the generator to the engine as well. So the machinery, we corrected the structural issue and the rigidity of the foundations, but then we followed on with a laser alignment. A precision alignment is always key.
Well, sure it is. As we know from our pleasure boat applications that we're all used to seeing,
Yeah.
it's alignment between the engine, the shaft, the struts, the whole drive line. And that's the part that you guys are most known for here in South Florida, is your ability to analyze alignment issues and correct them.
Right.
But here's a completely different application, and where that really makes sense is today we're moving more towards hybrid propulsion systems in the boats. And you're seeing a whole lot more EPA pressure, you're seeing a whole lot more IMO pressure, you're seeing compliance issues.
Yes.
And I mean, there are even automobile manufacturers who are announcing right now that they'll no longer produce internal combustion automobiles as of 2035. Well, it's only natural that that will go downstream into the marine industry.
Yeah.
Plus the fact that we're very sensitive to what's going on in the environment through boating. And while we love our pleasures, we want to do it responsibly. So the reality of it is we'll see more of these diesel electric applications in a pleasure boat marketplace. And it's not just aligning an engine to a shaft anymore. You actually have to align any and all pieces of equipment that you're operating.
I agree.
So the generator being driven by a propulsion engine, even our self-contained units that we use right now, be they from Northern Lights or Westerbeek or Kohler or Caterpillar or whomever, we're pulling power from them to drive these drives, but we're going to see more advanced and more commercial style applications in probably a lot of these big boats that are coming out of Europe.
I agree. I think the future, this electric propulsion is the beginning of a shift from direct drive to more electric-driven propulsion.
And I would have to think, while there's a lot of talk about hydrogen, the challenge with hydrogen as a propulsion system is going to be sourcing the hydrogen itself, storing the hydrogen itself, and developing the new technologies for hydrogen burning engines. So this is probably a much more logical, forward-looking solution to our propulsion issues.
Well, not to get off track here, but one other thing. We recently were involved in sea trials and commissioning sea trials on the LNG bunkering vessel that was built down in Texas.
Okay.
So so what they're doing is they're using LNG. They built a integrated tug barge that is using LNG on the main engine and on the tug part of it, and they have a barge with LNG tanks that they're going to use to bunker the cruise ships.
Okay.
So this vessel was built specifically for the future for bunkering LNG, which is the next, LNG starting
Liquid
to come
natural
in
gas.
because it's a pretty easy transition for a diesel to make it run on LNG.
Okay.
So that seems to be the next step. And then I can foresee where hydrogen will probably be the next
Coming
one
behind
after that.
Okay.
Once they go through but LNG is a very clean burning fuel. So apparently that's pretty good. And this bunkering ship was quite sophisticated.
But anytime you've got rotation, you've got a potential for vibration.
Yeah.
And there's an engineering solution if there's a vibration.
That's right.
But you got to find out where it is and what's causing it first.
You always got to find your problem first, right?
Before you can
Before you
identify
can-
your solution.
Exactly.
Absolutely. That's going to wrap up our segment at AME. Guys, thanks again very much for not only your continued support, but always wonderful information and things that we don't normally think about on the boat, but important considerations to comfort and to safety.
Thank you, Paul, and we really appreciate your support and the support of EBA.
Well, we appreciate that. We're going to wrap it up for this segment. We're going to break for a commercial, and then we'll be back with more.
Yacht Engineering Week 2021 has been made possible by Pantropic Power, the only authorized Caterpillar Power Systems dealer in South Florida. Florida Nautical Surveyors, your complete solution to all of your vessel surveying needs. And Robert Allen Law, exclusively dealing with the business of yachting. We would also like to thank Quantum Stabilizers, AME Solutions, DeAngelo Exhaust, MPI Marine Professionals Incorporated, Concord Marine Electronics, Lauderdale Marine Center, Marine Data, Isotropic, Dockmate, and Murray Ventilation Products. Thank you for joining us this year. We'll see you in 2022.